Hi everyone, welcome once more to Best Science Brand YouTube channel. Today we are trying to make an attempt on how to determine the end point for WAEC 2025 Chemistry Alternative E. Before we go ahead with this practical exercise, I have to say, those of you that watch the quantitative analysis which we posted about two days ago, that where we tested for copper sulfate and glucose. A little correction you should make on that particular video, the table. If you go to question C, I, and II, although I made a comment on the YouTube also. So you look at the comment section, I said it there. So question C, I, and II. Observation. You see the place we wrote reddish brown praise with it. Am I correct? No. So is there anything like that? Yeah, reddish brown praise. So you change reddish brown praise to brick red praise with it, not reddish brown. Because brick red is more acceptable in chemistry. Even though the two colors look are almost synonymous, they're similar. But brick red is more acceptable in chemistry. So in the CI section, the place you have reddish brown praise, that's the question that says C aqueous plus NaOH plus heat. So you now have reddish brown, change the reddish brown to brick red. Then you go to question CII, where we say C aqueous plus Ferlin solution A plus Ferlin solution B plus heat. What's the observation there? What's how what? Reddish brown, praise. Also change it to what? To brick red. So in that question C, the observation, the place you have reddish brown PPT, change it to brick red PPT. Because brick red is more technical and what we normally use in sciences than saying reddish brown PPT, so that not penalized in any examination. So having done that, so in this practical titration exercise, we are giving solution A. Solution A is what we have here, HCl acid prepared by dissolving 8.6 cn cube of HCl inside 1000 or 1 dn cube of water. So when we prepare this chemical, we use hydrochloric acid from BDH. BDH company, British Drug House Company, and then the acid has 37% purity and then density of 1.18. So that will give us concentration of about 0.103 or 0.104. That range more per dn cube. Then solution B is an acid salt, sodium hydrogen carbonate, prepared by dissolving 8 grams of this sodium bicarbonate inside 1 dn cube of water, and that gives us concentration of about 0.0952 mole per dn cube. So having done that, if you are seeing the channel for the very first time, as I always say, subscribe to the channel. How to subscribe? Under the video as it's playing, have the subscription icon, a small bell. Tap on the bell only once and get subscribed. Share the video to your classmates in WhatsApp group, to teachers group or students group, SS3 group. We have how do you share? Have some dots, about 3 dots under the video. Tap on it. You have the command that will come out that will show share. Tap on that share button and then move it to where you want to move it to WhatsApp group, and then students benefit from it as well. Then if you want to refer someone to this channel, tell them to search Best Science Brand on YouTube. Best Science Brand, Best B-E-S-T, then Science, and then Brand, B-R-A-I-N. The 3 words are joined together. There's no space between them. Best Science Brand. Don't space it. If you space them, you'll not see the channel on the YouTube. So Best Science Brand, the 3 words are joined together. You can search and then subscribe. Then, without wasting much of our time, we have the format for reporting the titration, burette readings, CN cube, final readings, initial readings, volume of AUs, rough, 1, 2, and 3. So we're going to perform the experiment now. In the matter of maybe less than 10 minutes, we will be done with the experiment. We get our end point, working end point. At the end point, we look at some calculations. We're going to look at 4 different calculations. So we have to be very fast about this video. 4 different calculations to show how you can ask questions on this particular specimen. Question can vary. So we're going to look at 4 different areas. Then after that, we're still going to look at the errors you encounter on the table. So let's make a mistake, because the table is 8 marks. The table is 8 marks for each examination. That is, get the table correct, is 8 marks. Then calculating your V8 is 2 marks. So everything about the table, from the table to V8 is 10 marks. Then for the fact that you did it, To get the 10 marks means that you have to be very careful what you're doing, because if you make any mistake on it, you start losing marks. At the end of the day, you'll be left with maybe 3/8 or 4/8. So we're going to point out those errors. And then also at the end of the video, I'll still teach you guys how to manipulate your table. If you have the end point, how you can get the table without doing the experiment. So we'll now start the experiment. So this is our burette. Bring it closer for your viewing. This is our burette. Then that seed. That seed, this is that seed, labeled A. I pour that seed into the beaker. Then I want to empty that seed into the burette. I have a funnel. You add it to check whether it's leaking. So it's not leaking. So you add more. So you see that, if you watch, you see that there's some acid left in the what? Funnel. So if you remove the funnel, you end up pouring the acid on yourself or on somebody's face. So what I'll do is I will adjust this a little. So, and then I'll remove the funnel before I continue to adjust. So let me tighten this. Begin. So that's okay. So the level is above 0. Let me decrease it so that the bottom or the main screws be on 0. It's coming down gradually. It's coming down. I want to start from 0. So the bottom of the curve should sit on the 0 mark. So it's there. So I'm starting from 0. So then I'll record here initial reading. I'll record initial 0.00. Everything here to 2 decimal places. That is it. So having done that, I'll now collect my base. Use the base. Label B. I'll pour the base into this place. Without wasting time, I don't have to waste time pipetting. So I can use the measuring cylinder to collect 25 cm of the base. It is above that. So I have a 25 cm cube of the base here. I empty into a conical flask. Having done that, this is material range indicator. So I'll get my indicator. Just add 2 drops. It's okay. Then shake this to ensure the homogeneous mixture. So I observed that the burette is leaking somehow. So what it means is that I have to adjust the burette because it has gone below 0. So that let me make it tight. I think it's better now. Adjust to 0 again, or I may change the burette. I'm going to fill the burette again and adjust it to 0. So we have to correct the error. So let's bring it down because some acid are inside the burette. So remove the burette now. I mean the funnel, not the funnel, and then adjust it once more to 0. So it's coming down to 0. So it has 0 there, so we can now close it. So it has stopped leaking now. So we can now start titrating. This is the base with the indicator. Bring it down and then start titrating. Allow the acid to run into the conical flask little by little. Well, I think the first one you're doing. So let the rate of dropping be consistent. So it's going down. I can see increase the thing a little. Let it run a little. So it's going down. Hope you're watching it.
Yes.
So it's going down gradually. Gradually. And the first one we're doing though. So say the first one we're doing, you have to be very careful. So I can stop it now and shake this and then continue again to titrate. So it's going. What color are we expecting? What color are we expecting? Yellow? It's not yellow here. Orange. So it's moving. It's going. So, why you watch the color? Orange is similar to yellow, but somehow glittering in appearance. And you see that if you look at the flower very well, some pink color are getting at the middle, showing that you're coming close to the end point. At the middle of the flowers, you see some pink color appearing a little bit. So let's stop here. So you see it's orange. So it's orange color. See, it looks more like yellow, but it's golden or shiny somehow. So the value here, you check, the value here is the bottom of the curve is sitting at the, even between 23, that is 23.5, between 23 and 24, 23.5. So that becomes your final reading here, right? 23.50 at the final reading. How do you get the quantity of acid used? How do you get it? Is it by addition or by subtraction? You subtract. This man this gives you 23.50. This is your rough. So when this I change color, what you do, you pour it away. You don't need it again. You pour it away into an empty trash can. So you pour it away and then rinse this thing again once more with what? Water. Okay? So you rinse this with this water. Pour away the base. The mixture, please. You collect another 25 cm cube of the base. Another 25 cm cube. You pour into the conical flask to repeat the experiment. Then you add 2 drops of indicator. One, 2. Then you swirl the flask. Keep it apart. This yellow color. Then the acid level has reduced. We now add more acid. You must not start from 0. You can start from any whole number of your own convenience. So must not be from 0. Perhaps let me start from 2. Okay, the initial here is 2 now. So since it's 2, the record initial displays 2.00. Now, let me ask you, assuming that the final here is to 3.5, the going to ask you is to 3.5. Assuming that this is correct. If you have to 3.5, what should be the value here? If here should be to 3.50, if this is correct, this is wrong. What should be the expected final? 5.50. Are you following?
Yes.
So, but we don't expect the rough to be correct. But the rough is done in a hurry, or in the first one we're doing. The 5.50, that means we expect the color to change around the 5.50. What we'll do is this. The 5.50 is where you expect to change. Subtract just one whole number. What do you have now? 24.50. So, run the acid without waste of time until it reaches what? Are you following it now? Yes. You expect to change around to 5.50. You add this to 5.50 to be here. Good. So run the acid, subtract 1 from where the final read which you expect. It becomes to 4.50. Run the acid until it reaches to 4.50 without waste of time. Then when it reaches to 4.50, take it what? Drop by drop. Because definitely it cannot change at this value. But if you change between the 4.5 and the 5.5, is that okay? So let's now see what we can do about it. So that is it. We'll now go back to our titration. I will then open the tab so that the answer will be entering without waste of time. My focus is going fast. My focus will be on when you reach 24.50. So, let me increase a little. 24.50, which should be here. I'll now take it drop by drop. So it's about there. Okay, it's at 24.5. Almost close. The end point is almost going to yellow. We'll now move it. Look at the way it's dropping now. Drop by drop. See the way it's going. Not too fast now because we are coming close to the end point. I think we should be there now. We are 25. 25 is already orange color. Already orange color. So here we have 25.00. So try what do you have? 21. Are you following this?
Yes.
It's a very simple thing to do. So what I'll do now is I'll empty this mixture. Rinse again with distilled water. Then measure out 25 cl cube of the base again. Almost there. What is it? 25. You pour it into this place. Then collect the indicator. 2 drops. 1, 2. Then shake it. Add more acid. Increase the volume because it's low. We'll start from 2. Choose any convenient level. So perhaps I may want to start from 5 at my initial. So after adding the acid, remove the funnel. The reason why you remove the funnel, I said it before, is because if you keep the funnel there, it will add additional drops of acid. So before you adjust the burette, the funnel should be removed first. Then you adjust the acid to your own comfort level. Let's start from 5 this time around. Okay, that is 5. It's on 5. Then right initial here has to be 5.00. So if I should ask you guys, if this is correct or value or more correct than this, if I write if this should be 3.00, what would be expected final? 28 to 8.00. So that should add them to 8.00. So subtract one whole number as a guide. You now have 27. That means run the acid fast until you reach 27. When 27, you go to the chain between 27 and 28. Then I think it drop by drop. So that's we have to make some prediction. Then we have this. The white tie here. So the white tie here, the essence is to dictate what? Sharp color change. So you can use a filter paper or any white paper. So I'll now open the tab to run without waste of time until I reach 27. So getting close to 27 here. So you can see 27 there. So once we are 27, I'll close the tab. So you have it, 27, you close it. Then you can take the acid drop by drop. So it goes inside. You open it a little. See how it's going now. Over 27, and we're expecting the change to be around 28. So one drop is 1 cm, 0.1 cm. Because in a burette, one reading is 0.1. It's like the way you read ruler or meter rule. One reading is 0.1. So a drop is 0.1. So 10 drops will move it from 27 to 28. So watch it carefully and watch the color. So we have the color, I think is all enough. So we have this and that orange color is clear. Everybody knows this orange. So 28. We have 28 here. 28.00. Subtract 23. That means this read is more accurate. So having done that, we'll do the third one. In examination, you must not do it 3 times though. You can do raw 1 and what? 2 and ignore what? 3. Provided that 1 and 2 are with each other. Are you following it now? Good. Because what they're going to mark in the exam, they're going to mark 2 columns. This one 4 marks, this one 4 marks. That's 8 marks. They choose any 2 columns and mark. Provided that the 2 columns are in accordance with the teacher's end point. So having done that, move to this one, to the last one. We pour away the mixture. And then, having done that, we now raise it, collect another base, the measuring cylinder, collect another 5 cm cube. Almost there, avoid bubbles. So that is it. The 5 cm cube, you pour it inside. And then you collect the indicator, add 2 drops, that's enough. Then I'm going to add more acid to increase the volume. I started from 5. I can use any other value, any other whole number. I can use 7, I can use 8, I can use 5, I can still go back to 1. But avoid using 0, 0 all through. Use 0, 0 as initial all through. It looks like pure manipulation. So we have the funnel. Add more acid. Okay. It's overflowing. We clean the body. Why the funnel is still here? Because there's some acid inside the funnel. So I have to reduce the thing below the level of the funnel, and then you can move down and move it down to around 7 cm. Okay, so that is it. We now have initial here 7.00. So if this is correct now, where do you expect the final to change? What the final reading now? 30. So let's move it. That means 30. Move it from subtract 1, that is 29. Move it fast until 29. You're going drop by drop. So you bring back the 24 plus. And then moving to 29 without waste of time. This is rushing. I think I have to adjust this burette a little because 30 is hidden in the clamp. So open the clamp and then close it once more. That's okay. Let me take this a little bit off. We are we're close to 29. I'll close it. Then move it drop by drop. So it's going in drop by drop. We are now 30. So, of course, the orange color appears once more. So, we have 30. That gives us 23.00. So, take a look at the table very well. In the table, all the readings are regarding to how many decimal places? 2. All of them 2 decimal places. All of them will begin to end. Any error, you lose their mark. 2 decimal places. All of them for beginning to keep it very well. There's nothing like this kind of reading in the exam. This is wrong. This is -1 mark. This one is not place. Now, not like a whole number. This is also wrong. So that is this. So how to find our VA? To find our VA now, what do we do? We ignore the rough. The word rough is not used because the rough is far above the other readings. You take 1, 2, and 3. 23.00 plus 23.00 plus another 23.00, all in what unit? CN over what? Over 3. Let's say you do experiment 2 times, you did only rough 1 and 2. You can use only 1 and 2 and divide by what? 2, not 3. The only reason, the only time you use the rough is when the rough is in agreement with this other right value. If not, ignore the rough. The rough is normally higher than the normal value because the rough is the first one you're doing, and when you do the first one, you're bound to make some mistakes. So that gives us VA as what value now? Our VA is what? 23.30. Please, when you divide, the calculator cannot give you 0.30. It don't give you 23 point what? So when you divide, your calculator cannot give you 23.30. It will only give you 23 point what? Point what? 3. So use your IQ and put what at the back? 0 to make 2 decimal places. Don't get right to 23.3. It's going to 3.30. And the unit. So when they're marking this, if this is correct, if this is in agreement with what the teacher recorded, this will be 4 marks. This one 4 marks. Any 2 column 4, 4, 8 marks. And then this one be this is evaluation 1 mark. This one another 1 mark. You're making how many marks altogether? 10 marks. You score 1. The reason why you score is this. You score complete 8 marks here if 1 is in agreement with their teacher's endpoint. 2, he did not record with any pencil. He recorded with pencil on the table, minus 2 marks. No unit on the table, minus 1 mark. Any reading, you write CN cube here, please. You don't have to write CN cube all through. This CN cube here covers the whole table. Cubic centimeter, not ordinary CN. CN means length. Not CN square, that means area. CN cube, please. Not square, not CM. CN cube. Then, no pencil on the table, minus 2. If you cancel the table, for those that might make mistake, if you cancel the table to build a new one, cancel it and build a new one. And that old one you did is a different value. Maybe you are getting 24 here, 24 here, 24 here. And your teacher's endpoint is 23. And you're getting 24 from the first table you did. And you cancel it and build a new one that will agree with what? The teacher's endpoint 23, 23, 23. That means you make a second table. The first one was not agree with the teacher's endpoint. The second one you did now agree with your endpoint. You lose minus 4. That half of the mark will go. So avoid mistakes. Mathematical error, when you subtract very well. Any mark error will take minus 1. Do it 2 times, minus 2. So all these things, all the little things to do may make you to be scoring maybe perhaps 4/10 in the whole table. Now this VA is what we call the end point. End point. That VA is what we call what? The end point. The end point means the volume of the acid required to neutralize 25 CN cube of the base. That's the end point for this particular experiment we are doing, 3.30. Although after the calculations, I will still say certain things about for those who are watching from other schools, because the teacher can use a different end point too. If your teacher uses a different end point from this one I'm using here, please use your teacher's end point. Use your teacher's endpoint, whether it's right or wrong. If you are using to 4.5, use your teacher's endpoint. I'll teach you how to build your table. If you are using to 5.0, use his own endpoint. But the calculations follow the same format. The endpoint can vary. The reason is why the endpoint can vary. Sometimes the acid we're using can have different density and different percentage purity. That can still affect the endpoint. And that reason is that the indicator you're using may be what? Expired. This one is a fresh one. Maybe an old or expired indicator. Or the concentration may be too much. That will say affect the end point. The base may be impure. That will say affect your end point. Then the water you're using may be impure. That can say affect the end point. The another reason is that the end point can say correct. The teacher may decide to work, vary its own, make its own different from other schools. So they're judging you based on your teacher's end point. But I will tell you when to use my own. You can use my own endpoint if it agrees with your teacher's endpoint with plus or minus 0.1. Yes. If your school endpoint agrees this range, then you can use my own endpoint. What that means? Subtract 0.1 from this. What do you have? 22.1. 23.20. Add point, what do you have? 23.40. That means 22, 3.20. What is the next value? 22, 3.1? 30. And what? 3.40. So if your reading is this, your endpoint, this or that, this will work for you in your school. So that is it. So we'll now go to the calculations and then look what we can get from this. So look at the first question here. That says solution A is hydrochloric acid. Solution B was prepared by dissolving 2.0 gram of sodium bicarbonate in 250 cl cube of water. Put A into the burette and titrate with 20 of the 5 cl cube portions of B using 2 or 3 drops of material range indicator. Repeat the experiment to obtain consistent readings. We have done the experiment and we've gotten an endpoint as 23.30. Then A says calculate the average level of acid used. We have done that one. B says from your result and information provided, calculate the concentration of B in mole per dN cube. The conc of B in mole per dN cube. And if you look at the question says solution A is HCl acid. Solution B was prepared by dissolving 2 grams of sodium hydrogen carbonate in 250 cm cube of water. That means B contains 2 grams of sodium carbonate in 250 cm cube. So we're going to look for the conc of B in mole per dm cube. So in the first question, we're looking for CB. We're told that we have 2 grams of B in 250 cm cube. So now 250 cm cube of solution contains 2.0 grams of the sodium hydrogen carbonate. We find the mass in 1000 cm cube. So 1000 cm cube, which represents 1 dm cube, will now contain 1000 cm cube times 2 grams all over 500 cm cube. When you solve this, we're going to have the error here. This should be over this is 250 back over 250 here, and that gives us 8.0 gram per dm cube. So this is the concentration in gram per dm cube or the mass concentration. You have to get it first. Then you find the molar mass of the B, which is sodium hydrogen carbonate. So from the information given to us, sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16 multiplied by 3. When you solve this all, you're going to have 84.0. Put your answer in 3SF, 84.0 gram per mole. Having done that, we're looking for CB. So CB given by concentration of B in gram per dm cube over the molar mass of B. So when you solve this, we now have 8 over 84. That gives us 0.0952 mole per dm cube. So if the concentration of B in mole per dm cube, which you are asked to calculate. Question BII says, find the concentration of A in mole per dm cube. The concentration of A in mole per dm cube. So go to the board. We're going to CA now. The equation of the reaction is HCl plus sodium carbonate. You know, sodium chloride plus water plus CO2. That's the equation of the reaction. We obtain our CB already from question 1 as 0.0952. Our VA is from the table 23.00 cm cube. Our VB, the pipette, is 25.00 cm cube. Ratio of our NA to MB. NA is the acid, MB is the base, is 1:1. If we separate them and write them differently, NA will be 1 mole, MB 1 mole. They're separated. You want to write them in form of ratio. So if you separate them, you cancel the unit. But you keep them different, you put the unit. So since you know your CA and you know your CB, look for CA, you apply the concept CABA over CBVB equal to NA over MB. So having done that, you go ahead and make CB the CA the solid formula. CA becomes equal to CBVB times NA all over VA times MB. Make a substitution. CB is 0.0952, VB is 25, NA is 1, all over VA is 23, the end point, MB is 1. So your CA calculated very well, you're going to have 0.103. Keep your answer, final answers to 3SF. Look at it. So that is your CA. Question BIII says, number of hydrogen ions present in 1 dm cube of solution A. number of hydrogen ions present in 1 DN cube of solution A. Solution A is HCl. So to solve this problem, you have to ionize HCl so you can bring out hydrogen ion. Have hydrogen ion and then hydrogen ion. Connect the acid to hydrogen ion. 1 mole is 1 mole of HCl produce 1 mole of hydrogen ion. In 1 DN cube of acid, you have the molar concentration, which is 0.10. So what is it again? 0.103 moles. Okay. We still continue. You can say 1 mole of HCl produce the number of particles in 1 mole of a substance is the Avogadro's number 6.02 power 23. Then we now have 0.103 mole represents the molar count of the acid. That number of moles of acid 1 DN cube will now give you 0.103 times 6.02 power 23, and that gives us 6.20 power 22 ions to 3 SF. So you can see the answer clearly. Number IV says mass of A in 250 cm cube of solution. Mass of A is the acid in 250 cm cube of the solution. So remember that our A is HCl. The volume given to us is 250 cm cube of solution A. The cost of the acid, which is the Ca, is 0.103 mole per DN cube. Looking for the mass of this acid in this volume. Remember that mole given to you as mass over molar mass. Or the same mole given to you as CV over 1000. If you apply this formula, you get mole. You have your concentration, you have your volume. You can then get number of moles. So when you get number of moles, you substitute here and get your mass. But in order to avoid wasting time, say this is mole, you can equal the two of them together. So now mass over molar mass equal to CV over 1000. Make back the subject. Mass becomes equal to CV times molar mass over 1000. So the concentration is 0.103, the volume 250. The molar mass of HCl, when you calculate it, HCl 1 plus 5.5 give you 36.5. So 36.5 over 1000. So when you solve it, the answer to 3SF give you 0.940 grams. That's the mass of the acid in 250 cm cube of the solution. So number V says the volume of CO2 liberated at STP during the reaction. The volume of CO2 liberated at STP during the reaction. So let's look at that. So to find the volume of CO2 liberated, we have to go to the equation. The equation is HCl plus this, sodium chloride, water, and CO2. You either connect the acid to the CO2 or you connect the carbonate to the CO2, any of them. So let's connect this one to CO2. So we have 1 mole of this, 1 mole of sodium bicarbonate, liberated 1 mole of CO2. Then 1 mole of sodium bicarbonate. You know that at STP, the volume of CO2, the volume of 1 mole of a gas is 2.4. Liberated 2.4 DN cube of CO2. And then the number of moles of the bicarbonate in 1 DN cube, which is the molar concentration, CP, is 0.0952 mole. We now liberate 0.0952 times 22.4 DN. And that will give you, of course, 2.13 DN cube as your final answer. Wish to keep the answer in CN cube multiplied by 1000. That will give you what in CNQ? 2130 CNQ. So having done that, this is the first way we are predicting that the question may likely come out. We look at another way, another format, another question, see on the same endpoint, same specimen. We're going to look at under some other calculations of a different way or a different pattern. The question can be what can be arranged. So stay connected. So we'll go to the another question from the same specimen that says solution A contains 3.80 gram hydrochloric acid per dn cube, 3.80 gram HCl acid per dn cube. Solution B was prepared at room temperature, which is 25 degrees Celsius, by dissolving 0.8 gram of SHCO3 in 100 CN cube water and diluting it to 1 dn cube. Put A into the burette and titrate with 20 of the 5 CN cube portions of B using 2 or 3 drops of methyl orange indicator. Repeat the experiment to obtain consistent reading. So we have done the experiment. We go to calculations. We go to the B equation that says, from your result and information provided, calculate the I concentration of A in mole per dn cube. We're looking for CA. To get our CA, we have to get information from the equation. The first sentence says solution A contains 3.80 grams of the acid per dn cube. 3.80 gram per dn cube means what the mass of per dn cube called? The mass of a solid in 1 day is called the what? The mass concentration, or the conc in what? In gram per dn cube. So let's go to the board. So from the equation, we are told that the concentration of A in gram per dn cube, which I can call rho A, is 3.80. The mass in 1 dn cube. They will find the molar mass of the acid, which is HCl, 1 for hydrogen, 5.5 mass of chlorine, giving us 36.5 gram per mole. Then the CA, the conc in mole per dn given by concentration in gram per dn cube, which is our rho A over molar mass. That becomes 3.8 over 36.5, and that gives us 0.104 mole per dn cube. That's the answer to 3SL, please. II says the conc of B in mole per dn cube. The conc of B in mole per dn cube. We go to the question again. The concept says solution B was prepared at room temperature by dissolving 0.8 gram of SHO3. So we cannot get the conc of B in mole per dn cube using mass conc over molar mass because the formula of B is unknown, S is unknown element. So let's go to the board and see how it goes. So we're looking for CB unknown. We're going to CA as 0.104 mole per dn cube. Our DB is the volume of pipette, 25.00 cn cube. Our BA is the endpoint, which is 23.30. They want to have 23.00 cn cube. The ratio of our NA to MB from the balance which is 1:1. So from the formula CAVA, CBVB equal to NA over MB. You make what's the subject? You make CB the what? Subject. So CB becomes equal to CAVAMB all over VB times NA. Make your substitution. CA is 0.104, BA is 23, MB is 1, all over BB is 25, NA is also 1. So when you solve that, you have 0.0957 mole per dn cube. Answer to 3SF. You see that? So go to the third question. So BIII says solubility of B at 25 degrees Celsius. Solubility of B at 25 degrees Celsius. And from the question, you are told that solution B was prepared at room temperature by dissolving 0.8 gram of SHCO3 in 100 cm cube of water and diluting it to 1 dN cube. So let's see how we can evaluate solubility of B at 25 degrees Celsius. Finding solubility of B, we use the formula DF. DF is called dilution factor times constant of B in mole per dN cube. Dilution factor is obtained using volume of B after dilution all over volume of solution B before dilution. Remember, you are told from the question that B was diluted from 100 cm cube to 1 dN cube. So the volume after dilution is 1 dN cube. The volume before dilution is 100 cm cube. Convert this into cm cube. That becomes 1000 cm cube over 100 cm cube. And that gives you 10. So solubility of B will now become dilution factor, which is 10, times concentration, which is we got as 0.0957. That will give you 0.957 mole per dN cube. Remember, this is different. 0.09, this is 0.95. After you multiply by 10, the same unit, mole per dN cube. So that is the solubility of B. So IV says find the relative molecular mass of SHCO3. Relative molecular mass of SHCO3. We'll still go back to the question. That says that we'll have 0.8 grams of SHCO3 in 100 cm cube of water, and that was diluted to 1 dN cube. So put the information there. We'll now go to the question. The solution. So in this question, we're looking for the relative molecular mass of SHCO3. And we are told that we have 0.8 grams of SHCO3 in 100 cm cube of water diluted to 1 dN cube. What do? We want to find the mass of this compound in 1 dN cube. That's the mass concentration. When I say 100 cm cube of solution equivalent to 0.80 gram of SHCO3. Therefore, 1000 cm cube of solution will now contain, which is 1 dN cube, 1000 times 0.8 over 100. When you solve this, you're going to get 8.0 gram per dN cube. That's the mass concentration. I will know that molar concentration CV given by mass concentration of concentration in gram per dN cube over the molar mass. You make molar mass the subject. So molar mass now becomes equal to concentration in gram per dN cube all over CB. So we now have this. The conc in gram per dN cube is what we got here, 8 grams. And then our CB got from the previous question as 0.0957. When we divide, we have a molar mass as 83.6. 83.6. But we are asked to find the relative molecular mass. Relative molecular mass, does it have any unit? No. However, you are asked to find molar mass. You have attached gram per mole here. So since it's molecular mass, we leave it like that without any unit. So we can take this as being our molecular mass to 3S. So the fifth question V says presented by mass of S in HCO3. Percentage by mass of S in S HCO3. So we're looking for the percentage of S in S HCO3. Before we do that, we want to find, first of all, the relative atomic mass of S. You have to find the mass of S before you find each percentage. You equate the compound to the molar mass, which is what? 83.6, which you got by calculation. S is unknown, hydrogen is 1, carbon is 12, oxygen is 16 multiplied by 3 equal to 83.6. So S plus, you add up this is 48, plus this is 60, 61, equal to 83.6. So S becomes 83.6 minus 61. Give me the value, please. 83.6 minus 61. Don't have a calculator. 83.6 minus 61. 22.6. We look at the percentage of S. So the percentage of S becomes relative atomic mass of S all over molar mass of the compound times 100 over 1. That becomes 22.6 all over 83.6 multiplied by 100 over 1. Please, what do you have by the answer? So 7.0%. So that is the answer. To go to the last question of today. So the third question we are predicting is this. A is the solution of a mineral acid containing 0.0260 mole in 250 cm cube of solution. B is the solution containing 4.0 gram of NaHCO3, solution bicarbonate, per 500 cm cube. Put A into the burette and titrate with 20 or 35 cm cube portions of B using 2 or 3 drops of methyl orange indicator. Repeat the experiment to obtain consistent reading. Calculate the average volume of A used. We have done that and we'll go to 23.0. That's the end point to go today, 23.0 cm cube. Then B says, from your result and information provided, calculate the concentration of A in mole per dn cube. The conc of A in mole per dn cube. Let's go to the question. Remember that in this question, the acid name is not mentioned for us. The acid is just called a mineral acid. So the name of the acid is not given to you. So you don't just assume that it's HCl. And I said the acid contains 0.0260 mole in 250 cm cube of solution. So we don't know the acid name, and there's no equation given to us. So let's see how we can solve this. We have 0.0260 mole of the acid in 250 cm cube. So the number of moles of the acid given to us is 0.0260, unknown acid. The acid volume given to us is what? Is 250 cm cube. And you're looking for the concentration of the acid unknown. How do we solve this problem? We cannot apply CAB over CBBB here because we don't know the acid name, we don't have a balanced equation to solve it. So we just apply concentration. N is what? CB over what? Over 1000. The form that contains mole, concentration, and volume. You make C the subject. C now becomes, by multiplying, C becomes equal to N times 1000 over V. So remember that this V you're using here is not the average titer. No, it's not the end point. The V you're using here is the volume given to you in the equation that contains 0. That is the 250. So now I have 0.0260 times 1000 over 250. When you solve this, you get the acid concentration, which is 0.104 mole per dn. That is the acid concentration in this question. Question 2, BII, we have to find the constant of B in mole per dn cube. The conc of B in mole per dn cube. And you are told in the question that, from second sentence, that solution B is a solution containing 4.0 grams of sodium bicarbonate in 500 Cn cube. To have 4 grams of the sodium bicarbonate in 500 Cn cube, per 500 Cn cube. So that's the function we need to solve, to calculate our CB. So for this number 2 question, mass of B is 4.0 gram. Volume is 500 Cn cube. We're looking for our CB. To get our CB, we have a mass. We apply concentration of B in gram per dn cube. We can call rho B all over the molar mass of B. Now, the conc in gram per dn cube is the mass present in 1000 Cn cube. This is 500. Convert. We now have 500 Cn cube of solution contains 4 grams. Therefore, 1000 Cn cube of solution will now contain 1000 times 4.0 over 500. If you solve this, you'll be getting 8.0 gram per dn cube. That's the mass concentration. We now find the molar mass of sodium hydrogen carbonate. That is 24. Sodium is 23, please. That is 1. Carbon is 12. Alt is 16 times 3. These are atomic masses, please. That gives you 84.0 gram per mole. So having obtained this, we come back here, substitute 8 as the mass conc all over 84, the molar mass. That gives you 0.0952 mole per dn cube. Question number 3 says mole ratio of A to B. Find the mole ratio of acid to base. Remember, there is no balance equation. So let's go on. So mole ratio of acid to base. We have to first find the number of moles of the acid. Na using CaBa over 1000. The acid concentration we got is 0.104. Our Va for the table is 3 over 1000. That gives us 0.00239 mole. You also find the number of moles of the base. That becomes CbVb over 1000. So your Cb is whatever Cb is 0.0952 times 5 over 1000.
Let them do it.
So that gives us 0.00238 mole. So number of moles of the acid average tighter, number of moles of the pipette. So now find the ratio of Na to Mb. 0.00239 here, 0.00238 here. Divide with a smaller value, which is 0.00238, 0.00238. That gives you a ratio of 1:1, the rest whole number. The mole ratio of acid to base is, of course, 1:1. Vi says the basis of A, and Ci is pretty what A could be. Then Cii say write the balance equation for the reaction. Basis of A is 1. That is monobasic. They ask state what A could be. Since A is monobasic, you can say that A is hydrochloric acid. Or you can say that A is triazonitrifide acid. So you can mention any mineral acid. Don't go to organic acid. Any mineral acid that is monobasic. Then Cii says you should write the balance equation for the reaction. Since you know the acid is HCl, from what is stated here, if you mention any of them, if you mention HCl, then I use HCl plus sodium hydrogen carbonate, giving us NaCl, water, and CO2. It's already balanced the way it is. You want to use HNO3. We now have plus this. We now have NaNO3 plus water plus CO2. Any of them can be used. So the acid you mention here is what we're going to use. But if you are not asked to mention the acid, you can just use, if they did not state the acid, listen very well, if you did not state the acid, you can just say HS because the number of acid is not known. I know that every acid contains what? Contains what? Hydrogen. So since the number of acid was not mentioned, you're not asked to mention, don't go and start using HCl. Let's say the acid have the balance equation and you're not asked to mention what the acid could be. You just write HS or HY plus NaHCO3. That give you maybe NaS plus water and plus what? CO2. So wind up here.